Hey, what's up guys? So welcome back to this series of tutorials for Lens Studio and Spectacles. Today we're going to focus on one particular aspect of working with this in this environment, which is TypeScript. So actually this will be quite a long tutorial, so let me get you ready for what you are going to experience. This is going to be nothing for this time, for this part, just nothing about Lens Studio and Spectacles. This little series, mini-series, is going to be subdivided in 3 parts. The first part is going to be this episode, and it's going to be about the basics of TypeScript. So how to ramp up if you are not too familiar with TypeScript. And if you have a Unity background, well, that's also my situation. So I learned TypeScript really thinking like a Unity developer. So I hope that that perspective could be helpful for you at least. And then the second part of this mini-series is going to be about all of these patterns of TypeScript, but in the context of Lens Studio. So we're going to take a look at all of these patterns of what you would do across all of the projects that are in the samples repository. So an extraction of all of those patterns. The third episode instead is going to be basically an overview in detail of this sample that is called Essential. And the sample called Essential is also available in our GitHub repo. And that sample is a very good start for you to ramp up and just see all of the things that we will talk about in the first 2 episodes in action. So this will be basically the schedule of this mini-series. This mini-series won't be delivered only once, so there might be some other tutorials in between. There's actually a lot of videos that I'm working on, so I'm excited to provide a lot more content for this ecosystem, which really deserve a lot of knowledge and spread informations around. So without further ado, let's get into TypeScript. Before I start, and I have around, 25 sections, which in my opinions, after seeing some stuff online, I thought this was the best way to subdivide all of these topics. We have 25 sections, and the first thing I want to do, first of all, is crediting another video that I will post in my description. So this video was from codecamp.com, freecodecamp.com, which is an amazing YouTube channel. I always looked, even when I was learning Unity back in the days, and C#. So I will credit the exact person and video down in my description. So you can take a look if you want. And then another thing that I want to mention is that TypeScript is overall a subset of JavaScript. So if you're a Unity developer, I doubt that you might have so much experience in these 2 domains. When I was starting to learn this stuff, I thought that the best thing to do was just building a website. So I built my website and I learned a little bit how those things work together. And it's very different from any game engine scenario. So I feel like if you work so much in game engines, you might get very much close eyes. You might have very much like as too focused on an expertise. So I recommend you to just look also beyond those thresholds. And I wish I would have done it a lot earlier myself. So I hope that makes you feel better if you are just starting now to understand these things. But it's relatively easy. So don't feel bad. It's just something that you can pick up super easily. Especially after this tutorial. So we're gonna go through and cover all of these topics together, and you're gonna have the repo that I'm basically inspiring myself from. You're gonna have it in your also referencing in the description, and you're gonna have also an enhanced version of this repo with a lot more examples and explanations and comments. So it's something that you just can look through and see all of the things that we're talking about, and probably some things that I will forget, because otherwise this tutorial would take a full week. But we're gonna try to keep it under 1.5 hours, something like that. I hope that when I edit this video, it's gonna be that length max. If it's less, might be also better. But let's start to talk about TypeScript. So TypeScript has a concept that basically fixes some issues from JavaScript. That's a way that usually people refer to TypeScript. TypeScript is basically, let's start with this first file. So this is called type in Inference. TypeScript is really providing you limitation of JavaScript sometimes. So JavaScript is a lot more efficient than TypeScript because TypeScript needs to compile to JavaScript to work. So it's really just, they call it like developer language more than actually production language. At the same time, JavaScript is very confusing in many ways because the main thing is that there is no type. So that's why it's called TypeScript. If you're not familiar with this concept, well, let's say, for example, that you have something that is called var, and then you call it a equal 10, and then you have var, and you call it b equal my string. So Just to give you an example, and let's make sure that we have a bigger way to show things here immediately. If you start just with this concept, right? This is a number, this is a word or a string. This is very confusing, especially for projects that becomes bigger. So if this is your first approach to this subject, I think this makes it immediately clear the fact that TypeScript is there for saving you from these very ambiguous cases where things are not too clear. And the inference is very cool in a way, because let's say that you have in TypeScript something like this. You don't really have a type, but let's say that this variable type, which is called let, blocks the scope of the type that is in this variable. Meaning that if this is now a boolean because it's true, and this is a number because it's 32, and this is a string, this cannot be somewhere else in the script. It can be enhanced, can be extended, but it cannot be something else. It's called blocking the scope. And there is also a better way to do this. There is another way to, no, it's not a better way, but there is also an alternative way that just not only blocks the scope of your variable, but also blocks the value of your variable. So it doesn't need to change in the future. So let's say that you have let here that is infer number 42, and instead to let you do const. And this infer number is 42, meaning that now if I go here and I do 45, this will be an error because you cannot change the value of this constant. So mostly this is something that TypeScript does very well and fixes things that JavaScript really doesn't do this well. And if you come from C#, as a Unity developer myself, I was thinking, well, that seems to me the standard. If you want to just do a type, you need to write a type every time, like that, at least how I learned. So it was something new for me to understand. And I was like, well, don't take for granted everything, because actually things are not, there's been a lot of work for making things working that well. So it's also interesting to understand how things evolve and really, and all of this technology, how to wrap around our habits and things like that. So I thought that that was very interesting. So let's go ahead and go through all of the type inference examples. So we have these three here, and we have a string, we have a number, and we have a boolean. TypeScript automatically infers the type on the string assigned value. So you don't see string here, you don't see number. So this is also something that if you start to work with Land Studio or generally more in this framework, you won't probably use this every time. You probably will just directly infer. You probably will just do something like this right away, which is not the right way to do it. So wait a second and I will show you what I mean, because this was a very C# way to do things. If you want to do it not implicitly, but you want to do it explicitly, this is actually what you would do. So you would just get the infer string, and instead you would just do something like this. So you see what happened here? So you actually declare a variable and then you give it the type. And this is the type. You can hover on this variable and you're ready to see the infer types. This is the equivalent to explicitly typing them. And the same thing for the array and for objects. So something like this. Now, if you say, well, why do I need to have let when I have boolean? Because in Unity, you would do something like private string, and then there is something like that. Well, you might wonder, why do I need to do this when I can do this in C#, right? When you are in C#, you can do something like bool my bool. Well, the reason is that under the hood, C# does have something called automatic default value. So the values automatically, for example, for a bool is false. But TypeScript doesn't have the same preps. So it's necessary to have that kind of additional prefix when you have variable. And then eventually when you do classes, this can become private or public or something like that. And we will see when we do classes all together. And you actually can see a lot of more resemblance of C# and TypeScript when we have classes. Because, for example, if you have a class in TypeScript, you actually will use things like this, which is very similar to C#. So this is going to be very much the pattern of Land Studio. So don't get worried about this. This is just to explain you something that you should know. So there is the concept of inference type in TypeScript. So meaning that you're inferring the type when you have it here. Something you might know is that you don't want to use probably var, and you probably never want to use it. You want to use it for very specific use cases, and I feel like very few times. I don't even want to bring it up because it's not good practice, at least from when you're starting. And then you can use const if you want to have something that is not going to change in the future. And then you're going to use let for a very general blocked scope variable, and that's it. And then we're going to have probably protected and all of the stuff that you probably had in C# before. This is really the important that you need to know. There's nothing else that you need to know in this case. And once again, I will provide you these files and super announced for you to understand all of the nuances and things that I will not talk about here. This is mostly first approach. Then we are going to talk about semicolons, because this is something that actually I didn't understand at first, and I was wondering why it would just work sometimes and not sometimes, or what's the deal there. So the cool thing or not cool thing about TypeScript is that you actually don't need semicolons. So you can do something like this, and they're both valid variables. That's a little bit to think, but when you are, I remember when you hire in C#, you really need to put this column, otherwise it gives you an error. But in this case, like this, both work. I recommend anyway to don't do that, because first of all, why? It's just, to me, if it works the same, I rather prefer to do this just because it makes me think better and understand what's going on. But there is also another reason. The thing is that both style works, but there are some use cases that are dangerous and safe. So let me give you an example. And this is what I was thinking when I just looked into it, because I was like, why? Well, this is actually dangerous because this could be interpreted as actually something like this. And this instead is safe because there is a clear distinction between the two. So this is something very nice that we need to know. So you need to know that you can also use the semicolon or not using it. This is not gonna, I just want to mention this because it's not gonna throw you an error. So that's really the thing that I want to mention here. That's the main thing. It's important to know, because if you don't see an error, you probably wonder, why is it working fine? It works actually. I think this is cool for things like this. So for if statement, it's just a very cool way to write it. I actually, like, I remember when I was working in some teams, there was in C#, they really want to force you to do stuff like this for some reason. I don't know, I always see this in C#, and instead I tend to see a lot more this in TypeScript, which is kind of the same thing, but it seems like it's a lot faster to write stuff. I might not go deeper on this one because it's not really relevant, but something just to mention. I think that could be something, the enums are pretty popular in game development. So even here, of course, in this case, we don't use the semicolon here, for example, which I believe is also the pattern of Unity, if I not remember this correctly. So this is the semicolon. The thing that you need to know about this is just that you can write it with or without, and it's just gonna work the same. Recommendation, personally, someone might disagree, and I would be curious to know what are other reasons, but I would just add the semicolon to be sure that there is a distinction between the two things. And also it's very much like a pattern that was very common in C# for me. All right, now we go into variable declaration. So that variable declaration is nothing but just a deep dive of the type inference. So let's go again and set type declarations. Oh, sorry, not type declaration. That was wrong on my end. Variable declaration, probably the first thing you want to know when you build a class. You want to say, I need a string, I need a number, I need a float, or something like that. Something I noticed is that in Unity, you specify integer and float with C#, and here, actually, there is just number. And you don't need to put that. And something that I noticed that initially also kind of irritated me quite a little, because I'm like, no, I want to just know what I'm doing. But no, there is number, especially in a student environment, just need to put number. So let's see what for variable declaration. This is like a stretched version of the first chapter where we have type inference. For variable declaration instead, what you have to know is that there is this old style that no one else, that is very much not recommended because it does not really lock the scope of the variable, and it's really unclear, especially if you work in teams. Then there is more the modern style, which I mentioned later, which is let, and then we have which is the constant that cannot be changed. So all you need to know is this one here, and what we talked about before was really just, once again, since it might be the first time that you're experiencing this thing, so a little bit of repetition really never hurt. Bar means that the scope is not blocked. This could be anything, anytime, any moment. This instead, the scope is blocked. So now is a string, it's been inferred as a string, and that will be always a string. And then here, instead, we have a constant which never change the type and the value. They never change the type and the value in your scope. So this is something to remember, but also since we are here, I don't think before we talked about primitive types, or just let's say the types that are the most important one to look into. So you can see that we have this basic primitives, which is when you are in Unity, same thing, but you call this bool, you call it float or integer or long, and then we have string, which remains strings, and then we have an undefined and null. So this is also something to know. There, of course, beside primitive types, there is a lot more. It depends really what are you trying to build, but objects, you might have, you're declaring something like an array. So for example, something like this. is another thing that you must know. So string array, ABC, number array, this is number. So you see how it's going here. It's always giving this this kind of semicolon here. It's like 2 dots. And then we go with the type here. So the structure is always here. This could also be like this in classes. Now it's going to throw me an error. But when you're in a class, you can do something like that. I think this is, of course, like functions are also types. And then we have generic, but we will go through it later. So this is really all you need to know for variable declaration and then basic primitives, which is also part of the inference there. Let's go for function. So let's go into the functions chapter. So if you're in Unity, you are probably very familiar with things that are more like something like a void, something like a coroutine for delayed calls and stuff like that. Now we go a little bit of a step back here because this is something that they make when you learn TypeScript also on the documentation. It seems like it's the coolest things, but also if you come from a Unity background, you might just think, oh, I hope it's there. Why they should have removed something like that? Because actually it is not present in JavaScript. So that's why TypeScript tried to tackle all of those things. So what is the cool part of function? A function is really just this kind of return type annotation. So we have something here, which is the return type of your function. Once again, this inversion of places is very similar, and I'm just always talking from C# person perspective. This is the big change. Usually in Unity, you see the stuff being in the prefix and not in the part between the brackets and the beginning of the function, but actually you see something like that here. So something you need to know that this is the very basic structure of functions. Another example here where we return stuff. So we return a string. So here, because we need a string here, we need to return this. If we don't return a string, TypeScript would of course catch the error. And this is also very common in Unity, of course. But we also have the void functions, right? This is very common in Unity because usually you're not returning a type, always you're doing stuff actually, and then you're calling those stuff in the update function or in the wake function and stuff like that. So usually you can also do a void, and the void type is just declared in this way. Why is this so powerful? Of course, because it allows you to debug things a lot better. And let's take a look at the declaration of the function. Once again, you might have something with some arguments. So let's say that we have something like this. Oh, I was about to forget something. Another thing that is pretty common in TypeScript is the concept of arrow function and hoisting. So this probably is the main difference. There are many nuances, but I think those comes kind of naturally, trying. But just to give you an example, hoisting means that because we have the concept here that, let me see if I can, wrapping. The concept of hoisting means basically that you can call a function even if it's been declared after you called it. Meaning that, for example, this function is like a normal function that says say hello, and just when you invoke say hello, it returns this kind of string wherever you want. But this is declared after that we used it. And this works because it's hoisted. Meaning that when we compile under the hood the TypeScript code, this function is actually compiled earlier at the moment. So this one is going to be at the top of the file, and then this is going to be recognized. So that's once again a little bit mind-bending differences between something like C# or TypeScript is the fact that you always need to think about that kind of second step of compilation in JavaScript. So actually what would be very helpful sometimes is actually do something like this, but for JavaScript. And I really want to do something like that in the future, so we have everything complete. But the arrow function, which is actually a very cool way to write a function, very similar to a function. So you see what's changing here. We just put an arrow here. It's like a function that if we try to do the same, we try to call it before, this is going to throw you an error because it's actually not hoisted. So when should I use a normal function versus an arrow function? The truth is that you can always use a function instead of using an arrow function, especially at the beginning, seems more of a flex. But the great advantage of this arrow function is definitely the concise syntax of the function. It's very cool that you can do something like that. When you get more into the details, I feel like you want to start to use these things. For example, in Unity, something that I was always used to use was the ternary operator, which is very cool to use, and it's very legible, and also one line that avoids you to do an if statement, basically. So I would say kind of the same vibe here, but it's also good practice to put type in front of this kind of const variable in front of arrow functions, because the thing is that it's not a function that you can reuse everywhere. It's a function that needs to be called in a very specific scenario where you are ready. It's a very specific function that needs to be called for things that are already available to you. So usually this is something that you call for callbacks. Let's see if I have an example, something like this. Example for you, for example, this is a cool way to use arrow functions. This is basically a function that takes a callback. So there is this callback here. And then when we ever declare a constant value, we basically call the function, and then we have this callback that manifests as an arrow function. So once again, you don't really need it, just you need to know that it's there. You might probably need it in the future if you want to have some callbacks. If you just hear the word callback, probably there is a good opportunity for you to use arrow function. So that's the way I would think about it. And once again, you don't have to know everything. I think it's good to go through this very long tutorial just to know what's available. And then whenever you start to use all of these things together, you just might remind something sometimes. And then that is the moment that you just want to use what you just learned. All right, let's keep going. We don't have any time to lose. So another thing that I want to mention in the context of function is asynchronous functions. So Unity, probably the most famous way to do a synchronous call is using coroutines. Coroutines are a way that allows you to run things in time. Very helpful, saves you so much when you want to do stuff like a boolean change during update or something like that. It just makes you think a lot differently. Or maybe you want to start something like a timer after a function, so you start the coroutine and you can quit all of the coroutine at the end of the function on disable. It's very helpful. So of course we also need something of that kind, and that's an asynchronous function, but we need something of that kind also for asynchronous function. This is just a general thing that is happening here. Let's say, for example, we want to do something like, this is really a basic one. So what is a asynchronous function is basically this, right? We are waiting for something to happen, and then we just do something that asynchronously. We log greeting 1 and then greeting 2, and then we do this and do that. So we have very established framework, step-by-step calls across all of these functions. So this is basic of it. Then another thing I want to mention is something that you might have heard before, and is promises. So let's take a look at what it means to work with promises. So we have two examples here. Promise. So this is pretty self-explanatory, meaning that you make a promise, really, and then that promise can be maintained or not maintained. And that's basically like try and catch, right? Something like try and catch that you would do, something like that. And then you handle multiple states if something happens or not. So for example, working with promises here, this is a very simple example where we have fetch user data, probably a very common thing for authentication. You have a promise type function. So notice how we have argument. Let's a little bit rephrase the structure here. This is the name of the function. We declare the function. We declare the type of the function, which is a promise. And then this promise has some parameters that probably needs to be resolved or fulfilled. So based on this user ID number, we need to get all of this stuff. And this is easy because we already have it as an argument, but we also need to check and setting a timeout, meaning that after 800, I believe milliseconds, we have a set timeout. And then if this is not failing, meaning that we go through this if condition, and if the user ID is something less or equal 0, we are rejecting it, so it's invalid. And otherwise we resolve this, and basically we just declare and fulfill those fields that we put as an argument in the promise. So very cool way to work. And the same thing here, async function that consumes promises. So something that you might see and you might ask, well, promise is asynchronous behavior by nature, right? But here we have function, and instead here we have async function. This is really the same. It's just a better way to describe what's going on. And this will behave as this because promising is generally of async nature. Even what you might consider instant promises is for nature asynchronous function. So I hope that was clear. And same other thing, this is something we will see very often, set timeout, something like that, waiting delays. Actually, something else I wanted to show is, we'll see in Lens Studio, that has a very similar structure, and we will go through this, is the delay callback. And we will go through this because it's very similar behavior, but just to let you see the pattern. See the set, there is a set timeout here, 1000 milliseconds. So we handle things asynchronously. The thing I want to talk about is custom function versus function. This is already something we covered initially here in functions. Well, we saw that usually custom functions are arrow functions, and because they are arrow functions, meaning they're not hoisted, so their meaning needs to be defined before they are executed. But something else I want to mention here is that, let's see an example that is something like this. If you have a constant function, you might ask yourself, well, a function isn't really constant there. It's something that takes argument and makes something always new. But that's a great question, for case you have that question. And the reason is that it's called constant because we see in the example here, it's permanent. So maybe cannot change what box points to, meaning that you can still use what's inside the box. So you can still call a function with certain parameters, but you cannot change the function. So you cannot redefine this function in another way. The basic types like boolean, string, number, and all of this stuff. Now let's go to see some more advanced utilization. So one thing that we will see very often is something called read-only properties, meaning that cannot be, it's really simple concept. And if you are familiar with using the computer, you see that every file has read and write permission, and this is just basically read only, so you cannot change the value as it is. There is also another thing that we will see very often, which is this question mark, and that means that is an optional property, meaning that we don't need to mandatorily fulfill this property. So let's say that we do something like this. This would work. So user name equal this because it's allowed, so here. But if we have an ID, we cannot reassign the ID, and if we have an email, we cannot reassign the email because these are just read-only and we're just consuming them. This often happens when you create websites and you have an authentication system, and then you allow the user to optionally change some parameters of all of that framework. That's probably what you are putting into if you go in this scenario. Optional is really just very simple, meaning that whenever you create a new user, you don't need necessarily to have a name. So meaning that in this specific service, age is not mandatory field to be filled. Something you also might see in TypeScript is something called type aliases. So type aliases are nothing but just a custom type. So you're allowed to create a new kind of type. So not a string, not a boolean, not a number, but actually your own type. So in this case, this is used for a particular framework where you have a very, if it's a type, this could be a required argument in other functions. So let's say that you have a function that takes like databases, right? Like probably are identifying database as one type, and then all of the database parameters are probably part of that specific type. Probably one of the easiest, as there's really not much going on. Arrays are just arrays. If you go on, you want to know how array works, if you come from Unity background, you might just as well know that this is the way, that it's very, very similar to the way we declare them. You must know that there is also an alternative way, an alternative syntax. It's really just your preference. Wouldn't think that there is a better way to do it. This is how you might see arrays in TypeScript. So look what's happening here. They say this is an array and is of type number, and instead this is just a number, but it's like an array of numbers. So same exact thing. Again, you can have something also that is mixed arrays, and we will go more into the details. Pretty cool stuff. You might have something like this. You might find like an array. That do not recommend to do something like this. Also never worked with this framework so much, but I don't know, like something tells me this is not a good choice. Are basically what I was just referring, looking through the array, and that's why I kind of had example. You see that this array has like mixed type array. Very interesting concept, right? And you might say, well, why I need it for one, hello, two world? Like, this is really just the beginning of what you might think is a union type usage. Actually, you need this for complex cases, like, for example, you might run into some API responses that require a different response, require a certain kind of response. I think that's probably parsing information from API responses is probably like it's a very big topic, because the way you interface those questions and like requests and responses variate across a lot of different frameworks. In that case, it's good to know that the response can contain different things, and most commonly is going to be a string or a number. A very helpful framework is something like permissions. So let's say that you have a type, which is a user role, which is a mix of 4 different roles, and you have different permission. Look at this, what you can do, an arrow function. Now we know what it is. And you can have a switch statement, and then you can say, well, if it is, if you do that, and so on. So this is Discord servers has probably something in place like this. Not entirely sure about that, but this is kind of like it seems to be. So that's for you, union types. Know that there is union types, so we know that there is a mix of types we can play with. Now we go in here and we go into something called tuples. Tuples are arrays with a fixed length and specific types for each position. So it's something basic to see, something like this. So look at this coordinate, has a number and a number. These are just 2 numbers of the coordinates. We have a person, which has probably the name and the age. And we have a boolean and a string with bool and log. If I say that a tuple is an array, you might ask, well, what's the main difference? Types, fixed length. So we see that we have 2 here. You asked me, like, I see that they're called tuple, and there are 2 different, in these 2 examples, there are always 2 parameters, 2 types, sorry. Say that you can have a lot more if you want. So you can have eventually more than 2. You can have 3, 4, and so on. This is pretty dry, I would say, very similar to the array chapter. All right, let's go to enums, very common in Unity, using enums. Enums are very similar. So this is literally an enum that I would do in any tracking with some other parameters, but very, very similar when you would get the direction of things. This is how you do enums. Even here, it's not much to know, to be honest. Something I want to mention is that a very good combo or enums and switch statement is something that I find myself to do pretty often. So just bringing it here for you, what you do is something like this. So you just like an enum, which has a very limited amount of options, and then based on those options, you just do something else. So this is something pretty common structure that I've seen in Unity so many times, and also appears to be in TypeScript easily. So once again, I hope you find comfort into thinking that TypeScript can be very, very similar to C#. We are talking about interfaces. Interfaces are very, very important, very useful, especially in this when you're trying to standardize stuff and you try to scale up all of the things that you're doing. Basic interface is usually something like this. It's just basically a schema of a certain amount of parameters, which come with the value, of course, of the variable, and then with the type of that variable, and then you basically just have like a series of parameters that fulfill what you need. We can have something like this, which is in my case, it's myself. So we have this something like this that is like, we have like examples, ID, email, user ID, and so on and so on. So this is the way we have also interface, but interface can also have, that's when you start to get like useful in terms of like to build classes or kind of structure there. And we still have the read-only, we still have the Google ID, we still have the optional value here. You will see these interfaces being very helpful to you will be in the implementation of classes. So let's say that you have something like this. Let me see if I can show this example. Say that you have this interface, which has called drivable and has these parameters and this method. Every time that a class implements this interface here, you need to have absolutely this, and of course this parameter that comes from that. if you actually missing stop and accelerate, this would be no-go. This is not gonna work. This is very, very helpful. For example, into a UI kit, you might have an interface for buttons, and that means that every variation of button needs to implement a interface button. So that could be something very helpful if you want to structure your code that way. This becomes quite useful. In fact, after we talked about interfaces, we are going to talk about classes. So let's go ahead and we go into number 13. We're going to skip the 12 because it's too specific, and you will find it into the repository that I will post on the description. Let's talk about classes. So classes are usually something that looks like this in vanilla TypeScript. And this is a very common use case where you have a user and then you build a constructor that assign values to the parameters and the properties of the user. Why don't we have something like that in Land Studio or Unity? Because Land Studio and Unity actually do a lot for us already. But you might have in different ways multiple reasons why we actually don't need often a constructor. Thing is that in Land Studio or Unity, sometimes you just assign all of these values directly in the inspector. And usually these values or types or methods that you're invoking are actually built within the API of those game engines. So to make it short for you, the engine actually manages the object life cycle. So you don't need to have a sort of like log created successfully, something like your object, like for example, if you are in Unity or Land Studio and you don't assign, a required field in the inspector, and you try to play or you try to refresh the preview in Land Studio, it's gonna throw you an error. It's gonna tell you, hey, this is not gonna happen. But if you actually drag it in, you're just gonna have a problem. And when that happens, that you get a notification that not going to happen, is really because there is under the hood a constructor that takes into consideration those assignments that you need to do, maybe more visually or maybe in another way through managers or built-in in functions that are already part of the game engine API. This chapter also is going to be pretty simple. I already know that in Unity you can have a variable that is going to be private, public, read-only, and so on. I think this is more about syntax. In fact, if you are something like this, I know that for TypeScript, public is actually default. So as long as we don't write private, the variable is public as default. From my memories, it's not really the default setup of Unity. Unity, you actually need to put, if you want to expose actually that variable, it's actually private as default. So I would say pretty major difference, like TypeScript for Land Studio, but then you will see that there is definitely a good distinction to do that within the Land Studio engine. So don't worry about that one. Mostly you have two cases. So the first one is a public read only, which means that you can see but not change. So you can basically only read. And if you have a private read only, it's basically a private variable, meaning that you're just going to see within the scope of the class. So private read only internal identifier. You might see is actually something called protected. So if you see a protected read only, something like that, and we will go more into depth with this, but basically protected means that you can only access this field. So forget about this for a second. Protected means that you can only access this field between the major, like the base class and the extended class that derive from that class. But then the fact that you say here protected read-only means that any class that derives from my class is just going to be able to see but not change this user ID number. So just a little bit of a distinction. Another thing that you might see is something called getters and setters. So getters and setters, it's pretty self-explanatory. Getter means you are accessing a property. Setter means that you're setting a property. So if we have a class user and then you have a get and then you have a set, meaning that you are setting this private variable in a way. So notice the pattern here. You have actually two private variable. This is also a very valuable pattern, which I actually highly recommend. You will see something like this probably before in Unity or Land Studio. And these are getters of these. It becomes cool this way to work because, for example, you want, I don't know, like you want to get the age, but you want to get this age, and then you wanted to say it's completely wrong, don't do it, but you want to say return this age plus a number, so something like that, and then you want to do something else. So you, instead of just like variables, you're just going to access variable and just have like a function that can be injected in when you are getting those variable. So it's pretty cool, and probably very professional way to work, I would say. Avoids a lot of bad code. You might ask, why do we need getters and setters? Well, just imagine that your class is accessible. The class basically a number here as a variable, which is very important. So let's say that you have like a public number info, and you have this kind of string. So this is public and you can access another class. At the same time, imagine that you want to know who accessed that. So imagine that you have a getter which get this important info, but then as an argument requires actually an argument. So you actually requires, for example, the ID access to that variable. So this is how getters and setters are very important. It's a way to improve security. It's a way to improve just patterns of all of your way you work and so on. Very helpful for theming. You have like a theming aspect. So you want to access to a certain theme. Whenever you access to that theme, you just like, so you set, let's say, my theme, but that means that I'm gonna have a callback, and then I'm just gonna call something that updates my theme. Okay, we talked about protected variables before, but let's do it again. Once again, we're learning stuff, so let's do it. This is the main difference between all of what we are seeing here, and sorry about the squiggle. Means that you're accessing everywhere. The file modifier can be used from anyone. Of course, private is the complete opposite. And then protected, as I mentioned before, this is the main like information you need to get. It's like within the class and its subclasses, not accessible from outside the class hierarchy. Perfect for sharing data with child classes. So, for example, you have a class which is a vehicle. Let's just put it here. This is a vehicle that has like a brand, an engine, a serial number, and then you want to create a car, which is basically a subclass of the vehicle. And then we have that protected that needs to be, so let's go see where it's protected here. The start engine can only be used in subclasses of car, cannot be used in any other thing. So if I'm just gonna derive something from something different, it's just gonna come from there and not from, sorry. So this means that this protected method can, if I reference vehicle, cannot actually use using start engine. I need to extend from vehicle. That's what I wanted to do. Okay, so let's talk about constructors. So once again, constructors are something that you might not need to know so well for something like the environment of Blend Studio or Unity. However, it's good to know what they are and when they are needed versus when they are not needed. So when constructors are not needed is something like this, where we actually have a simple class without constructor, and we assign values to our parameters from the start. So we already know that there is a specific value that is defined for these properties. When actually we need it, when that, you might already understood the pattern there. You might need it when these variables here are not assigned to any value. So this constructor will need it because it needs to be like the way we assign this variable. And look, for example, and the way that we are creating basically this new class, we just create product, and then the product automatically pick up the pattern of the constructor. Again, this not really needed in Blend Studio or Unity, but just so you know what it is. And it's good to understand all of this stuff with a very like 1.0 understanding, so then you can start your knowledge from there instead of understanding things a little bit more vaguely. So this constructor is mostly for that reason. It's complex very easily though. There are so many ways to do it. I don't think we should do all of them. Just to give you an example, we went through before with those optional stuff like union. If we think about what we did before and all of those advanced types, we could think of something like this. So this is using the union types and optional parameters we actually went through before. So you notice that within this class, there is not actually just one constructor, but there are 4. So you can just build a user, not in that way, but you can build it in this way. So you can just have different parameters. About something pretty cool, which is abstract classes. So abstract classes are kind of a must know. And if you know already all of this inheritance concept, please keep. Of course, here we are going through all of the TypeScript goodies and the way to do things in TypeScript. So I hope that even if this case might be very similar to what you already know, it's not. It's something new. I'm gonna go through for any sort of level of knowledge. So, like simple these abstract class animal and extension of animal, which is dog. Let's go through it. Animal class, we have a constructor, and then we have some method, which means that is shared implementation, meaning that it does not need to be implemented mandatorily, but is there. And then we have a concrete method again with share logic once again. Then we have some abstract method. So we have the abstract mark in front of the method. So these methods should be absolutely implemented in the extended classes. So this is something that you might know between an abstract classes. If you have an abstract method, it means that whoever is deriving from that class needs to use that methods and have them. So must implement all of the abstract method. So pretty straightforward. This extend animal. In fact, like think a very basic example or primary example of this is like Inland Studio or Unity when we say, oh, but like class needs to derive from model behavior, otherwise probably nothing else is working. So in that sense, deriving all of your methods from an API, right, that already has all of these abstract classes that allow you to access those methods, and then those methods differs on what you are, basically what you need. But then you might say, well, what's the difference between something like that and something like an interface? Because also the interface, if we went through before here, kind of the same. Like you just implement an interface, right? Like other classes. So you have a drivable interface, and then you can implement this into a class. Well, the main difference is, first of all, it's not a class, so it's a whole interface, and we know it. But I think that the main difference is that the interfaces is more of a contract. I think that's the good way to explain it. So for example, use something like this with interface. Like you can have multiple. So let's say that you have the interface A and interface B, and then you have this class that implements this interface and this other class that needs to implement two interfaces. So that's why it's more of a contract. So contract-based behavior versus more like behavior, because you're basically trying to share some stuff that needs to, and if you really want to make that implemented, you kind of abstract and then you do something like that. There is also the concept of overriding, which is not, I think in C# you really need to make sure that you are overriding, but here basically the overriding, it's already happening somehow because you are in the abstract class, you not override abstract methods, but you're basically overriding a shared method, because the shared method, which is, for example, in this case is sleep. So this is shared logic. You can implement that sleep, but just do something different. And that means that you are overriding the other. So in the extended class, you can have like kind of methods, one that is a new one. So it's just part of maybe this new class. What is abstract that needs to be implemented, that because it comes from the abstract class, like an of extending the behavior or basically overriding the behavior. So doing something with the abstract class behaviors. The thing I didn't mention about abstract classes is actually this super function. So the super function in this case, once again, this might be already handled by the game engine we're using. So no worries about what we will do next. But so you ever see this, it's actually calling the abstract class constructor. So if you are doing and you're coming up with your custom abstract class and extended class pattern, you probably will run in the need of super. Super, what it does, basically just calls the base class before accessing the properties that are part of the extended class, but are also part of the base class. So what happens if we don't call super, these things that are here, so all of these abstract classes that we have move and eat won't work. So we couldn't call this stuff. So basically super is just an initializer in the extended class regarding the abstract class. So generics are basically, you might have seen this T word here, this T character, sorry, no word. Generics are basically one function that fits it all. That's probably the most common way to define it. Means that you can just generically apply the same formula to many use cases, I would say. And in this case, I think this example explained it very well and very simply. Then of course you can just scale things up and do something different. But you will see that here, like at first, simple, it is this simple generic that always get the first element of a certain array of any kind. So we have a string type, we have a number type function and Boolean type function. So, and it's very repetitive, right? Like we need 3 functions to do basically the same thing. But then we have this that does exactly the same, but for any type. So in that case, that's why you can just use it, and that will kind of same thing for you instead of doing 3 times. However, become quite a lot more complicated when you just scale this pattern up. Actually, things, because you can apply this pattern to everything, right? So you can apply to functions, you can apply to interfaces, you can apply to classes, and so on. So you can see, for example, application to classes. So let's take a look at this. This is a generic class. So if we have a generic class called storage, you have everything basically is a T. And so like these can be applied to many things, because you don't really have, you have add, all, remove, but in a storage there might be so many different objects, right? So for that case, you might just like something like this. So you can use for different, you can use it for string, you can use it for numbers, something like this, and so on, so on. So this is the main use of generic. They're very common also for arrays mostly. So I think probably at like a special section for generic arrays. Arrays are very helpful. Generic arrays are very helpful for what we showed before, which is the first number, the last number, or getting basically avoid this sort of repetition. Also are very cool for filtering. So let's say that we have some filter array find item. So you're trying to find a certain item, you still need to have like find item for each item. Trying to map, same thing. You probably need like a specific type to type, right? So even there, this could be very useful. Some examples here: even numbers, long words, number strings, word lengths, and we just call the same things here, but with different things. So not this like filter array numbers, filter array words, and so on. These are very cool stuff. I would say like I'm just showing you the things that probably you will see more often, or also the things that are going to be more useful to you. Then of course there are so many advanced use cases, but it's something that might be more user specific, and you might not need it. And you will find everything in the repo that I will share with you. Alright, generic class. So same concept really applies for classes. Same thing, really. Again, I think as long as you understand the concept, like it's just like repeatable pattern and scales up and scales up. Repeated class, we have a generic class. So this class name is called container, but the type is not defined of the class. Then we have a private value T, which is probably the same type of here. And then we have the initializing the value, so you're assigning the value here, and then you get the value, you set the value, and string the value. And string, maybe the value is something that needs to be to string, so to understand what's the value. This is something that you can do with classes too, so pretty interesting. You can have like that also for classes. By doing this, so I also to give you always some examples of just like things. So I don't know if you ever saw like a queue structure, but for example, doing a prototype for where queuing the generation of 2D and 3D images and 3D models. Those two are two different things, right? Like one type is like 2D images, the other type is 3D models. So what to do? You need to do a queue, right? You need to do a queue and asynchronously understand who's the turn of what's the item that needs to be processed for that kind of generation. In this case, I actually used a queue in that case, so for doing one by one. You have the chance to do things together, you might not need a queue, but most of the time you might need a queue also for maybe allowing some performance improvements or something like that. So that's kind of a use case. Right, I think most of the things that we had to go through have been covered. The last 4 chapters are mostly about things that you might see and kind of to do things more than actually understanding things about. So a concept you will probably touch or will be in contact with is the type narrowing. Type narrowing means that basically you just need to narrow down what's the type that you need, and you could do that in many ways. I think one of the most basic implementation and comprehensible could be something like this. So if you take a look at this, for example, you see process inputs. So the inputs could be one of these, and you have a simple statement that tells you, well, if input is this kind of type, something with it. this is actually very common because also in XR, I feel like this is something you might go when you do things like, is this like a director interactor? Is this a director interactor? Is it a long distance interactor? Is this a hand interactor? Like that, and you do things and you just handle the interaction feedback differently based on what interactor you are dealing with. So that's something pretty interesting that I have done so many times, but you didn't know that's the name is like type narrowing. So it's like a very fancy name to define basically this if statement. It's easily more advanced, right? But the thing is that the main goal of the type narrowing activity is really just narrowing this, understanding what type narrowing in this. I think type narrowing is a big thing in TypeScript because all what TypeScript is trying to do in a way, right? So of course it's like a very important part of language, and that's why, like, putting perspective, you might ask, like, why are we doing this? It's just a very common pattern. This is actually something pretty important, and I'm sure maybe if you went through something like that in Unity, it's something very common. So narrowing, definitely interesting, something that you might have done and you didn't know that's actually the type narrowing. Similar concepts that we are gonna take a look now is in operator. And here, let's take a look at the basic in operator usage. It's very similar to the narrowing, but instead of saying basically type of, we say, hey, is this parameter inside of our object that we are defining? So we have a type shape has been defined here. Shape can be square, rectangular, or circle. And these three things are interfaces. So look how cool this pattern is. You create a type that needs to implement one of these three interfaces. If you just go to a function and you say, hey, look, if size is in actually shape, do this or do that. This is also very simple, and kind of you feel like you can actually structure things a lot more efficiently. Instanceof is also very similar. So actually this, look how opposite are all of these chapters. So generics make actually the opposite of this possible, meaning that you really don't need to, you can actually use you can use any type for doing anything. But this is exactly the opposite, right? Because sometimes you might actually need those types. I think this is more of like a question and answer, right? This function you see right away, Instanceof. So is animal an instance of dog? And animal is a type that we have here. So let's say that we have a class dog that is stand animal, and then we have animal, which is our base abstract class. So we have it before. Definitely gonna be yes. So very similarly to the in operator, which checks if you actually have in your interface, in this case, or wherever you have in your class or in your type, you have actually this. So you're checking basically a property. We have also something called instance. And instance, now that you know what is a base class, we have a base class animal. So let's say that we have animal base class. So this is an abstract class. It's actually the same example that we did before. So pointed us to that file directly. So we have an abstract class, and we know that dog extend animal. So that's definitely an instance of animal. If animal that we are checking it here is an instance of dog, well, do something and something else. So kind of like the Instanceof. Look how the type narrowing, in operator, and Instanceof are basically the solution to that might come out of very generic handling of types. So kind of an answer, I would say here, because once again, like script is made to recognize types. So that's the main of the language. So that's why it goes always back to that from the beginning. Okay, so we are at the end of this walkthrough of TypeScript. Always tried, let's say, to relate things to XR or Lens Studio or Unity patterns, and I'm gonna try to do it also in this last chapters. But I thought this was a very cool pattern. These examples are very usable in my opinion, so let's see how this works. So discriminated unions. Go through all of these options until they are available. So here we see a simple, we call it state management example. There are three interfaces. We know what are interfaces because we went through it before. So interfaces are basically this structure where you are, this contract that you're trying to implement across many other places. This can apply to many types. Most commonly, you are implementing interfaces in classes. Just saying. So here you have an interface, right? And then you have a type, and you are combining these types into, these interfaces into a type. So this is really the discriminated union. So why is it called discriminated union? Well, so we have something like this now. So we have something like this. So let me give you an example. We have something that is called union of types. We saw this. We have a status and then a union of 3 string literals. We have like types. Then we have this kind of union of interfaces. So this is also a union because you have a type that is a union of 3 interfaces. But then we have something called discriminator, because the discriminator is a property which is in common across all of these 3 interfaces. So because this discriminator is in common between the 3 interfaces, we can actually do stuff like this. So a function with exhaustive checking. So this pattern, what does it do? It's basically a switch statement that goes through the state, which is coming from this type, and then it gets into that type, and then it goes into status. And if the status is loading, meaning that we have these 2 things here. And so we can just log the progress message and so on. Same thing as happened with this one, success. So let's see where is success is here. So we have data and timestamp. We have here this timestamp. And then we have the error. So we have error string, code, and retrievable boolean. So very cool pattern. And then at the end, you need to have also a case where things, if there is also something like that in Unity, you can just like null or something like that. But here you can do something like a constant value and call it never. So exhaustive check never state. At the end, we have the never state, which is just basically the TypeScript way to say something like this. So something like, you missed something, this is impossible, you need to arrive there, and something like this. So this is just a way to say that you did something wrong, but basically the default state, which if you add all of the cases, you will never reach that point. So ideally, you will never reach this point because this point means it is an error. If you enjoy these kind of tutorials, do you think I go in depth enough? If you think I do not, just please below and just tell me what you wish I would do a little better. Otherwise, if you really enjoyed this video and you find it valuable for your education, please go ahead and subscribe. This really helps me to just do more video and get more visibility. Thank you so much for being here. I'll see you next time. Peace.